Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Hey there, meteorologist Aaron Tuttle, back with you again. It is Saturday lunchtime. It's about 12:30. We're going to do a Facebook Live here for you, a YouTube Live, a Rumble Live, and a Twitter Live. So thanks for joining me on all 4 of those platforms. We're going to talk about the severe weather for today. So, yeah, you know, we need some rain. I know it may come with a little bit of something we don't want, but hey, beggars can't be choosers, and we desperately need it. So thanks for joining me. We're going to talk about the threat for severe weather quickly for this afternoon and evening. Let's find out where it's going to be, what kind of situation we're going to be in. Is it going to be hail, wind, tornadoes, all that kind of stuff. So thanks for joining me. Please like and share this video. Tell your friends and family about me. Again, we're going to do this in 2 parts. We'll do a quick version, so in other words, like a 4 to 5 minute version for your forecast, and then for those that aren't too busy and want to stay for a few more minutes, we'll talk a little bit more in the details as to the hows and whys and whens and whatnots. So how about that? Will that work out for everybody? All right, currently out there we've got a lot of clouds, and this is actually kind of a helpful thing. It's a limiting factor for heating up the atmosphere too much today, which is good because we have a weak cap in place. Not a strong one, but a weak one. And a weak one is easily broken. This will prevent that from being easily broken, and some of the models indicate it may never break because of this until later on tonight. Get to that in a second, but what we can tell you is, my goodness, these winds won't stop. I mean, 58 to 60 to 66 miles per hour. This is just today alone. Last night, winds are up over 70 miles per hour out in northwestern Oklahoma in the Panhandle. So, are you over the wind? I know I am. So the winds will continue, though, this afternoon. They're still pretty gusty here out of the south and southwesterly at times out here in western Oklahoma. Again, the wind speeds right now, the biggest corridor is right over central Oklahoma and a little bit to the northeast. We have some gusts over 40 miles per hour. Now, when you take a look at the drought conditions, this is why we desperately need some rainfall. We keep getting rain in this area. I mean, that's great, but you guys need to share the love and bring it back west, because we're going to be hurting here in Oklahoma City and surrounding areas if we don't. And we'll have these fire dangers that usually is always out here, including today. High fire danger. This will keep creeping eastward here into the I-35 corridor, which means a lot of homes if we don't get some rain. So let's hope for some rain. All right, so here's a look at temperatures this afternoon. We're going to top you out into the 80s out here across western Oklahoma, about mid-80s for the most part. Right about 80 here in central Oklahoma and parts just east central. Then when you get up into Tulsa and far eastern Oklahoma, maybe still a few upper 70s hanging on, but only by a thread. So otherwise, a pretty mild day out there. Now we look at the wind gusts. We talked about those winds gusty here across the central area of the state, northeast. As we head into this evening, those winds will calm down only by a fraction. Overnight, they're still quite gusty in the evening. How about tomorrow? Let's go into Sunday. There's windy behind the front in the morning as it moves on through, so a cold front will be coming through in Oklahoma City by daybreak. And then, once it gets pretty far south for the afternoon, those wind gusts start to die down across most of Oklahoma. The exception will be down here where there's going to continue to rain. There'll be some storms down here across southern parts of the state. So that's where it's going to be windy and rainy, but you can see those winds do creep up. Look how close they get here to Oklahoma City. I mean, just on the north side of town, not a big deal. Wind gusts at 13. South side of down toward Norman, wind gusts back to 32. So, hey, I'm trying to get the wind out of here too, you know. Let's not even take a look at what's happening there. That's more wind. So people keep out of me. When's the wind going to end? Never. July. Here's a look at the severe weather threat from the Storm Prediction Center. Slight risk goes almost all the way up into Canada. Trails all the way back down that I-35 corridor here to Kansas and Oklahoma and down to the southwest toward 44. And we have a mixture of all 3. So this is the tornado threat, high up here, well not high, but circled up here across the north. Little brown shading continues from Oklahoma City to southwest Oklahoma, all the way up into the north and east. This has been expanded in coverage. And the 5% ring, just so you know, is a probability legend. It's a way to try to tell you how high the threat is. In other words, if it's a low threat, a moderate threat, a high threat, it's saying a low threat. Wind, same idea. Hail, same idea. So it's kind of all in that little thin sliver. A close-up view of that here in Oklahoma. Slight risk continues in the yellow here across central, southwestern, northern Oklahoma. A low threat of a tornado, otherwise golf ball size hail. Now here's the ticker. I think a lot of these storms that do develop will be big hail makers. I mean, not big as in size, big as in numerous. I think there'll be a lot of hail with these storms. So roofers will be happy with that. But most of them should be around golf ball or smaller. So hopefully we can get more of the smaller hail versus the bigger hail. The indices right now don't indicate large hail, anything bigger than that. Right now, the severe weather threat for Tulsa also continues up here in the north into northwestern Oklahoma. Nothing for the southeast as far as severe weather magnitude. Your threat is for tomorrow. Here's a look at the tornado potential for today. It is on the low side here across central, southwestern, northeastern Oklahoma from the National Weather Service. And the flash flood potential, yes, you can get some flash flooding even in a drought. These storms produce 2 to 3 inches of rain in about a 30-minute to 1 hour time frame. That's how that happens. If you look into the timing of this, anytime from about 5 o'clock to 9 o'clock. And the reason why it's such a large window is because models kind of develop storms here early on, and then later a secondary round here, both at different times. This one right about 5, and this one right about 9. And that's the reason why, because the cap breaks down here in southwest Oklahoma later this evening and allow those to develop. Now here's a look at the flash flood potential for Sunday. You can see how it comes just into the Oklahoma City metro area on the south side of town. And it does stretch up to the south side of Tulsa, but it's mostly for the southeastern third of the state. We'll get some good heavy rainfall for you guys. Flash flooding. Here's the threat for the rainfall forecast. So we could see up to 3 plus 4 inches of rain in this little area here from McAllister, Muskogee down to Fort Smith and up toward Fayetteville. So again, keep that in the back of your mind. Flash flooding actually kills more people than the other severe weather parameters combined. So kind of keep that in mind. It's a silent killer. You usually don't pay a lot of attention to it. All right, let's take a look at the latest forecast here from the high resolution HRRR model, which will show you those showers and storms try to bubble up here. Now, this model's actually been struggling to produce convection. I mean, it's had a really hard time, and each run is starting to get a little bit more excited, but it's also a little bit later. So in other words, this is 6 o'clock. It's just now getting things fired up. And then by 7, it's got it lining up here across this little corridor here. As we head into the 8 o'clock hour, you can see more of it. You see one little helicity track here, which indicates some hail. Yeah, potential tornado. And then as we head into 9 o'clock, 10 o'clock, that moves on up into northeastern Oklahoma. And there's some development down here across south central Oklahoma from 11 o'clock. And then this model hits that secondary batch, not around 9, but closer to midnight, whereas other models are much sooner than that. Point being is there'll be a secondary round that develops, and that moves through the central Oklahoma region. So again, that's potential for some flash flooding in the overnight period. That continues all the way through 4 o'clock, 5 o'clock in the morning. Now, a cold front making its way through Oklahoma City Metro by this point in time. It was a marathon and all that kind of stuff going on outside. So do expect some rain the very first part of the morning, close to daybreak. After that, this activity does shove to the south, so it will be a timing thing. Hopefully we can get it all out of here before most people hit the pavement. All right, now rainfall amounts. If we go through a blend of each of the models, the take-home here is look at how much it ranges. Anywhere from 1.5 inches to the yellow is about 4 inches. All right, so there's your blend of models. There's the high-resolution NAM. It's got some pockets close to 5 or 6 in some of those areas. There's its bigger brother. Here's the high-resolution HRRR model. It's got spots of 5 to 6 right around McAllister, south and west. So what they do is they try to showcase where some of the heavier storm training is going to be, and it just keeps dumping rainfall. So we're going to get a lot of rain in some of these areas, but you can see the take-home is roughly along the I-44 corridor, give or take. Not much happening out here in northwest Oklahoma at all. Sorry about that, guys. I know you need it. All right, here's your forecast for temperatures today. Right about low 80s, right around 80 here in central Oklahoma. Otherwise, we're looking at 60s for Sunday and Monday. And then we head into the Tuesday, Wednesday time frame. We start to warm things back up again. Overall, those also getting warm. You do see that low temperature of 42, but hey, at least we're not into the 30s on Tuesday morning on the 26th. So that is some good news. No sign of a freeze or anything like that, so that's good. So let's keep our fingers crossed. There's no more late season, last minute cold fronts that come in and do that to us, but that's the latest look at that. Okay, so that's your quick 5-minute discussion on just what's going to happen real quickly. So basically anytime after 5 o'clock is fair game for central Oklahoma to see those storms bubbling up. And believe it or not, it's still not 100% guaranteed, but I think we're leaning more toward there will be at least a couple of storms that get going. Most favored area for severe weather, it could be here in the metro, but probably a little bit more north toward Stillwater and maybe parts of northeast Oklahoma for that first round. Secondary round coming in from the south and west. A lot more rain with that, some hail with it. The tornado threat is low. It's not 0, but I do expect at least probably a couple here in the state, and that is anchored across central Oklahoma. So could that be the Oklahoma City Metro? Sure. We're in the zone of the activity, so anything's fair game at this point. What's going against us is a south-southwest flow, south-southwest wind at the surface. You really need to have more of a southeasterly component, so that's a limiting factor, which is good. for tornadoes. Also, even though you do have some moisture, we're right around 60, 61 for dew point, because some other things going on, our lifting condensation level where the cloud base is a little high, and so it's kind of hard to get a tornado in that environment. But if you can get some good pooling of the dew points, that's what's going to be key. We'll watch this afternoon and evening where we get some good dew points, may pool around 63 or 64. If that happens, that would be most favorable area for a potential tornado, just because it's a little bit better ingredients for the storm to ingest and lower the cloud bases and everything. So that's on the table. But otherwise, you'll probably see a severe thunderstorm and or tornado watch go up around 4:30, 5 o'clock, assuming we get the towers building up. And then after that, we'll just track it. And I do plan on being live this evening for covering tornadoes. Should it looks like a few of those storms may try to do that. Otherwise, expect hail out of those mostly, with some pockets of wind. Of course, we don't need the storm to produce wind. We got wind already. Just go outside and feel it. Let's see. If things look really interesting, like before kickoff, so to speak, I may do another live, just kind of a quick mesoscale analysis, like around 5 o'clock, where I would pinpoint maybe some interesting things. We'll see how that goes. But otherwise, that's the short version. So thanks for you guys for stopping by and watching that. I'm going to go into a little bit more detail for the longer version, take a look at some soundings and stuff. So if you want to hang tight, we'll do that another 5 minutes, and then you guys can go on about your day. How about that? Does that sound good? All right, so let's zip on in here. I'm going to show you a couple other different models too. Okay, so we have obviously a lot of different convective models that try to produce severe weather. So this is one of our high resolution short-term models, and it doesn't do anything hardly at all. See, it tries to fire them up around 4 or 5 o'clock, and then they just collapse. They just deteriorate. And that, believe it or not, that was actually the stronger signal over the last couple of days until just today, this morning. And models do struggle. Sometimes they're not infallible. So here's a look at the 3-kilometer NAM, which really hasn't been doing too hot this year. It's been over-promising and under-deliver. Today, it under-promises. So here's 4 or 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock. Doesn't do hardly anything at all. Then it gets that secondary push later on this evening and overnight down south, and then also with the front up north. So that's the big difference with that. That's why I'm saying it's still not 100% guarantee we'll get those storms to pop here. We're kind of on the fringe of breaking the cap, and we've got a lot of cloudiness moving through, which, by the way, I can show you that. Where is my... Did I close that? Hold on. Yeah, I think I did. Why did I close that? I don't know, but I should open that back up. All right, let's do that for you. I looked at this earlier when I was checking out the data. All right, so we're going to show you a couple things here on the satellite view that you can pick out. So first off, we do have a nice low-level trajectory of moisture coming in from the Gulf of Mexico, which is one thing we've lacked really most of this season. But you can see how it's coming into the north. It kind of curls up to the north and east, though. Now, it will kind of pool on this end here in central Oklahoma, because we're on the western fringe of it. Now, if you do see this enhancement out here, well, that's actually due to the jet stream pattern. So if I take a look at, let's do this deal here, the water vapor. You can see how that trail of moisture gets just lit up. And that's because this is a jet stream. So this is the rush of wind at 500 to, good grief, millibars up to around 250 millibars. It's where the wind is just like a river of air is just piping in. And so it's lifting all that moisture and condensing in the form of the cloud cover, starting on the eastern Texas Panhandle, stretching through Oklahoma. So this is actually helping to limit some of the heating out there, which is kind of a good thing, and can actually, believe it or not, can help to keep that cap from breaking. It's not allowing us to get as warm. So that's one of those things that we've had a lot of these weak conditional type setups versus something that's, just a gimme. But sometimes it happens. All right, let's go with a couple of other models. These are a little bit more aggressive, and they usually do pretty good fairly often. So let's take a look here. This one fires these little supercell, can look to up around 6 to 7 o'clock here over central Oklahoma, and those move through northeast and east central. Then they die. Well, I say die out. Some of them kind of die out. Some kind of hang in there. Then we have that new development, south central Oklahoma, that kind of runs on the south side of the metro, and that continues for a while. So you can see how you could get a lot of heavy rain. You have something like that, it just sits over one spot, and then there's the front that comes through, and then there's more activity for Sunday. So again, here's Sunday afternoon and evening, and just lights up like a Christmas tree down there with a lot of rainfall. Pockets of severe weather, but definitely potential for some flash flooding. So there's a couple look at some of our other higher resolution models that, and this one right here, as a matter of fact, is usually really aggressive. Let's see what it does. This is funny. It's usually the most aggressive, and it tries to get stuff going around 5 o'clock. And then it kind of moves up to the northeast, and that's it. Doesn't do anything else. And then, let's see, does it get the evening stuff going? No. Completely different. So each of these models use slightly different physics, and that's the fact that we have to use slightly different physics should let you know that we still don't have this quite figured out. In other words, we're still trying to figure out the physics of the atmosphere. We have a pretty good idea, and we use some different measuring and ingredients for that, but different formulas, but don't always get it right because we don't know. We're just taking lots of educated guesses, and we're just trying this and trying that. All right, so the main energy of this upper level storm system is up here across the northern plains. What that means is we get the tail end of it here, a little bit of tail end energy coming through the panhandle this evening. So it's not a big brute forcing event. It's very subtle. We don't have little bright colors moving through Oklahoma itself. So that's why this is still in the conditional probability aspect of things. We do look at the 7 o'clock position of the 700 millibar lift. You can see a lot of it right here along the front. So we do have the lift at the front that will provide overnight tonight, especially gets moving. And then tomorrow, you can see most of that lift is now into eastern, southeastern, and southern Oklahoma. So that's where the bulk of the storms will be there. And then let's see, finally, let's take a look at the newest. Let's do the newest HER. How far out does this go? Well, that's too new, not far enough. All right, so we'll go to this one. And let's do this guy here. And then we're going to do a forecast sounding just to see what the data on this looks like. All right, go back there. Okay, so this is the look of the dew point value where the moisture is. Let's go to 5 o'clock, 6 o'clock. Okay, so at 6 o'clock, this is kind of what I was talking about earlier. I think we talked about this at lunchtime yesterday. These little areas here in green are low to mid 50s. The blue is the good deep moisture around 60. So we have a situation where you really need, believe it or not, into the 60s for like really good storm development, tornadoes, at least in this part of the country. Other parts of the country can get away with different things, but here are the body of Oklahoma. That's usually what we need as one of our main ingredients. You can also see kind of a southwest wind that kind of is in this direction here, all the way up until it hits to about central Oklahoma. So there is a convergence. So the convergence line, for really good, or at least decent, believe it or not, at this point in time, is right in this vicinity right here. All right, so in other words, this would be where your best position for storms to develop. Now from here, the cap is a little strong down here, so you would eliminate this potential in theory. And then you'd say, okay, so let's focus then on this area here. So that would be the most likelihood, in my opinion, by 5 and 6 o'clock where storms will develop, just based off of this forecast map of where the best convergence is, where these arrow barbs come to meet. So you got to have something to get things going, right? And then you can tell, let's see, let's go to here. In this particular mode, the rain starts, it's bumped up the dew points now to 68. In other words, it's because it's got some rain on here. So let's see what that, we already looked at that earlier. Let me see, oh, forecast sounding, that's what I wanted to do. I was like, I knew I was want to do something. All right, so 5 o'clock. Let's go to 6. That had the best look to it. So we'll do just on the west side of Oklahoma City. All right, so in this particular case, we'll get a forecast sounding. And the profile says, okay, possible hazard type of a tornado. In this particular case, we have somewhat of a classic supercell structure. We do have some directional shear, and we have speed shear. And it's actually pretty uniform. In other words, these colors you see here are all pretty much equal in length for each section. And if anything, they're going up higher in each section. So that's good. The very top part's a little weak, but that's okay. All right, so but the issue is here we have pretty high LCLs, lift and condensation levels. So this is a detriment of getting a tornado. The storm will rotate, it'll produce some hail, and it might even try, get a little funnel, a little wall cloud, but this may preclude getting a tornado to develop. It has a temperature of 80 degrees and dew point of 62. Now this is assuming we do hit 80 degrees. At this point, the convective temperature is 82 degrees. So according to the model, we would have to hit 82 to break the cap. If we don't break the cap and the storms don't form. If we do, or this is off by a couple degrees, we break the cap at least in a couple areas with that convergence and we get some storms to form. Now they have 209 meters per second squared of shear. In other words, you need about 200 for a good rotating supercell thunderstorm with the potential for producing a tornado. So we've got that on the ticket. The Cape value is up around 2,000, so that's plenty of instability. Let's see what else. Oh, here's the other deal. So what's interesting is the forecasted hail model in here is on the low end. In other words, it's not overly aggressive. It's just actually just under 1 with the lapse rates around 6. Normally, if you really want big hail, these would be much higher, between 1.5 to 2, for example, or even greater than 2 for really big hail. And then for really having enough cold hail formation, circulation, development, you like, and for the structure of the storm and the strength of the storm, you like these lapse rates to be 7, 8, or even 9. That's off the chart crazy. So in other words, these are almost marginal severe type indices. So that's why the atmosphere is kind of struggling. It's not a perfect setup. It doesn't have most of its, S together, if you know what I mean. So it has enough ingredients to kind of give us some trouble, but not too much to give us too much trouble, if that makes any sense to you. So it does have potential for a tornado that, if it were to develop, could be significant, which means an EF2 tornado on this scale here when it compares to past events, analogs, and the indices that it has to measure all that stuff. All right, so let's go to 7 o'clock. All right, so this is when storms are ongoing. I'll just pick Oklahoma City itself. See if anything's changed. And yeah, actually the lifting condensation level is still high. The wind's a little bit more out of the south, so that's a little bit better for a tornado genesis and the length of one and the lifespan of one. But we're cooling things down. We're at 78 degrees. All right, so now we've lost enough of our instability to even break the cap. So if it hasn't done it by 6 o'clock, according to this, it's not going to do it at all until things cool down. And that's where that secondary round gets in. So let's go to 8, 9 o'clock. All right, so let's go to this point. And I believe, was it this model, I think, that already produced convection down here? I believe it was. So let me go to 9. And let me just see what this does. Yeah, because I looked at this earlier, and then I looked at so much data, and I lose track of what I looked at. All right, so what happened was, actually, our sin starts to go down. Our sin is the measurement of the cap. If it's over minus 50, so it's like minus 75, minus 100. It's above minus 100, so it's like minus 150, 200. Cap's too strong, you never break it. But once you get down to the 50s or less, no problem. Now I'm thinking, less on the negative side, so closer to 0. So between 0 minus 50, that's a breakable cap, no problem. Once it gets above that, you're going to have some other things going on to get it to happen. So it actually has that cap getting down below 50 in that little sweet spot. And that's why those models produce a secondary round of storms that does move back into the metro after about 9 o'clock. And then we looked at this was the HER, that's right. So it was the NAM, I think, that did this. So let's go to the NAM real quick. All right, so let's go. Let's see, that was 5 o'clock, 6 o'clock. And then it was 8, 9, 10. And then it busts things out late. Okay, so we'll see what this looks like real quick. All right, so there's minus 50 there. Now if I go back in time, all right, there's still that little sweet spot of where the cap is right around just less, so there's minus 40, minus 46. So that's where it's breakable. That's minus 70. And that's 0, obviously. So it's got some storms bubbling up at this point in time. And that's right at 7 o'clock. So before, at 7 o'clock, it builds the cap in for a little bit, and then it weakens it a little bit later on this evening, closer to 10 o'clock, and then some. So it's kind of like, that's why there's 2 windows where the models try to produce storms. All right, so let me think anything else I can show you. Cape and shear overlaid. It's a small area where things kind of get going and has a really good chance to do much. It's kind of in this little corridor. For this evening. So it's nothing out here and it's nothing out here. All right, let me think anything else. This is the significant tornado parameter, the fixed layer. And let me show you. The brighter the colors indicates where the best ingredients are for tornadoes. You can see that does include that same little area we highlighted. So it's kind of bounded like this. That doesn't always mean you're going to get tornadoes in this area, but if other things go well for the storm, according to the storm's point of view, then it's got this kind of an environment to work with, and some of the better indices are kind of up here, which is why I kind of mentioned they might be a little stronger, more potent, north and east side of Oklahoma City, towards Stillwater, for example. It's maybe toward Osage County or just east side of Ponca City, something like that. That's where some of the indices are a little bit stronger during the evening hours. That'll be a spot to watch. Tech model, which I haven't been doing so good this year. I'm really disappointed in it. But it does try to fire off some of those storms here at 4 and 5 o'clock. They move through. Nothing really very strong in the data. There's one little helicity track there, which says the supercell will be strong enough to get at least some hail going. The other's just kind of a cluster of multicellular garbage. And then it tries to do a secondary round right there later on, around midnight, and then it cut the front that moves through. And then, of course, there's southeast Oklahoma, some of that back building into central Oklahoma. And there's some helicity tracks in here. So could that be embedded potential tornadoes? Could be. Also some hail within that, and just very heavy rainfall. So we kind of have a 2-day severe weather period, according to the data here across Oklahoma. And then last one I want to show you. This one is a experimental. It's a 1 kilometer, and it's been actually doing fairly good this year. So let's see what happens here. It's going to try to fire some supercells off right here at the 6 o'clock hour from right around Oklahoma City, points north and east toward the border in that favorite area I mentioned. As we head into the 7 o'clock hour, it does have some helicity tracks on those because they come into Payne County and maybe Creek County. So again, potentially could be a tornado, but also could just be some hail makers. Same thing here as we head into the next hour. So there's 8 o'clock. There's one down here just east of Norman. The rest of these guys have moved northeast and northeastern Oklahoma, but they've gotten off the best ingredients and they died out. They diminished. Even this one down here in Norman, once it got a little bit too far east in the next county over, Seminole, it started to die out too. So if they get too far off that axis, they don't do too well. So that's why I say this threat is really localized, very, very small. All right, here's, let's see, 10 o'clock. There's that new development down southwest into central Oklahoma, and then those kind of move all east overnight. A lot of heavy rain. Could be some embedded severe weather sometimes with those, but otherwise could be more of a potential brief flash flooding situation for up to around midnight. So there you go. So we've looked at extra data, kind of give you the idea. It's not a huge tornado aspect as far as the data goes. It's enough of one to at least probably produce a couple. It only takes one, obviously, to cause some problems. So at least it's not an outbreak or numerous or anything like that in the data. So that's good. A lot of rainfall. That's good too. At least the data's showing a lot of that over central Oklahoma. So that'll help with the drought conditions. Hail, of course. I think numerous, like in my numerous, I mean probably like a ton of pea-size, marbles, dimes, those kind of sizes. And you probably get a few golf balls thrown in there in the cores, the main core of the storm. And that's typical in a supercell. Otherwise, probably a lot of 1 inch. There'll be a lot of the reports that come in. Let me think. But I'll watch it for you this afternoon and evening should something a little crazy. So if you got anything to do, you got plenty of hours for anything happens. We're talking 5 o'clock, so go out there and do some running around if you need to. And then just check back with me. I'll be doing live. It looks like there's going to be a tornado or two develop out of any of these supercell storms. And we'll just keep an eye on it. Well, thanks for checking in with me, guys. Hope you have a great rest of your day. Stacy Queen, I missed out. What was said about Creek County? Well, we were talking about the storm that would probably weaken as it got into Creek County because it's getting off the instability axis. So that probably is good news for you, I'm assuming. We'll kind of keep tracking all those. We'll watch radar trends and we'll walk you through it as things change. So that is it. I think that's all I got here for you. Let me do a couple things here. Robert, you know what's funny is he would attend every now and then. I don't know if he does anymore. I don't care, but so he's asking why are the models having a tough time showing much of the storms on this particular model site, and each model site is going to have a little bit different way to display the data. But in general, we talked about the reason why some of the models are having a tough time producing storms is because there is a weak cap involved, and it's not a complete guarantee that it breaks. But although it is looking more and more likely, since it looks like the moisture is there, and we're already at 78 degrees, so we only got like 3 degrees to go. So if you figure a degree an hour is 2, 3, 4 o'clock, you should be able to get it. So it'd take a pretty significant change for that not to occur. I can go look at something here real quick. So let's do that. All right, so this is a look at the Oklahoma Mesonet. So we have this tongue of upper 70s right here in the zone that we would require to get those storms to go, kind of in this little area here. And this is where you have your kind of a weak convergence zone. So you have a southwest wind all in this region, you have your south wind in this region, and so this is like your best, and it's a weak convergence, don't get me wrong, it's not strong at all. If we had a stronger cap, I wouldn't even be considering this. I wouldn't even be on the air right now. I'd have said, clear it, enjoy your day. But because the cap is really weak, doesn't take much, even with this type of setup. And if you notice, temperatures are in the upper 70s to right around 80 already. And then down here in this little section here, so this is why, again, those storms may have a tough time once they get east of this heat and instability axis. If you look in here, you got a lot of low 70s, right? And it's cloudy out there already. So this part of Oklahoma won't be warming up as much as definitely as this section. So it's kind of like you get the best heating here to pop them off, right? And they go gangbusters. And then every county they go over east, they get a little weaker. And then they get a little weaker. And then when they get to this point, they die out. So that's kind of how that works. And that's why you can have storms in it that are potent, but only in a very small area like this. And so that kind of goes with the highlight from the Storm Prediction Center as to why our risk is right here over the I-35 corridor in Oklahoma City, for example. All right, so I think that's pretty good. I mean, there's really not much more I can tell you. So Jolene, how do you know the cap is weak? Because we just looked at it on the forecast soundings. So you must be late to the party. Don't be late to the party. If you are late to the party and you're having a problem being late to the party, let me give you a solution. So I don't want you being late to the party because you miss out. So let's see. Let's do this. Comment. All right. So hit that link, and you can opt in to get a direct message from me through your Facebook Messenger, and that way you'll never be late to the party. You'll always be on time. Because I can't guarantee that Facebook is going to tell you. I can't even guarantee that the YouTube, these others, or Twitter's going to tell you. Although I think most of the time they do. I rarely hear complaints from them, but it's possible. But I know Facebook always has a lot of complaints. So there's Terry. I didn't get my notification. So make sure though, if you do opt in, there is 2 buttons you can press. One is to watch live now. The other one is manage messages. You have to hit manage messages. That way you re-opt in so that you know, so Facebook knows you want to be notified about the next one. And that way you don't miss the live broadcast. Okay, so April, I see you. Well, the good news is, as I end this, you can go back and watch the replay. If you fast forward in about 3 minutes when I come on, and you just want to cut to the chase, I give you the forecast about from that point forward. It's like 4 minutes from there, and then it's done. And then we just spent some extra time here talking about some of the extra ingredients and stuff that's causing things to do what they do. But I'll be back later on, either 5 o'clock, just to discuss the environment and the ingredients if it looks like things are really getting pretty good, or I'll just wait and see storms to develop, and then if it looks like they'll be tornadic, I'll cover those as well. Either way, I look forward to seeing you guys later. Have a great rest of your day. Be safe. Make sure you got your plan ready, just in case you're impacted by severe weather. Know a place to go, where to seek shelter, how to seek shelter, all that kind of stuff. This crawl at the bottom always tells you that information 24/7, 365. That way it's grilled in your head, and you always know what to do. Okay, guys. Talk soon. Take care.